Guide for BT can be and today we learn about transposition of transmission lines of transmission lines transposition of transmission lines. Okay, why we need this transposition? First of all, we have to know. In last class we calculated the inductance of a three phases LA, LB and LC for untransposed unsymmetrical transmission line. The equation is 2 into 10 power minus 7 ln root d12 d13 divided by r dash minus j root 3 by 2 ln d13 by d12 for first phase. In LB phase, the inductance is 2 into 10 power minus 7 ln root d12 d23 divided by r dash plus j root 3 by 2 ln d23 by d12. For third phase, 2 into 10 power minus 7 ln root d12 d13 d23 divided by r dash minus j root 3 by 2 ln d23 by d13. Okay, this is for the equations of inductances for three phases. Okay, now we can go to the here. Assume that three transmission lines untransposed case, transmission line A, transmission line B and transmission line C. ABCs is there, it is not transposed. Okay, therefore LA, LB, LC can be calculated by using those formulas. What you understand from these formulas is, here it is clear that the solutions having imaginary terms, and from the conclusion LA is not equal to LB is not equal to LC. The inductances are not same. If inductances are not same, then the voltage drop is not same. Voltage drop in A, voltage drop in B, voltage drop in C is different. Therefore, at the receiving end, the voltages VA, VB, VC are not balanced. We are having unbalanced receiving end voltage we received. Receiving end voltage is present at the receiving end. It is not good for the transmission system. We have to make LA equal to LB equal to LC. How we can make this LA equals to LB equal to LC with the help of transposition. Transposition, name it indicates that it changing the positions. Transposition is nothing but, the meaning of transposition is change the positions of the conductor. Change the position. We want to explain what is meant by define transposition. It is periodic swapping of a position of the conductors, of a transmission line. Called periodic swapping. Okay, swapping means it's continuously changing its position. Now, how we can make the transposition? How we can make the LA equal to LB equal to LC? Here, This is conductor A. I will take the okay, here each and every color represent each and every phase. This is conductor A, this is conductor B, this is conductor C. Okay, here in both the cases there is no difference. Okay, okay, I will draw once again the untransposed case. One, same length. Those are the three conductors. The conductors A, B, C, it is untransposed. Untransposed means here conductors are not changing its position. In this case, it is transposed. In transposed case, the conductors are changing its position. Length, both the cases is same. How it changes its position? First, I have to. Here, assume that this is the position 1, this is position 1, position 2, position 3, all the cases. At the total length is L, the total length is L, it is divided into 3 parts. This length is L by 3, L by 3, L by 3. Okay. So assume that it is a first interval, this is second interval, this is third interval. In first interval, A at position 1, B at position 2, C at position 3 for first interval. In second interval, A at position 2, A at position 2, C at position 1, B at position 3. Okay. Now, C at position 1, A at position 2, B at position 3. Next, third interval. In third interval, third interval, C at position 2, B at position 3, A at position. Okay, here B at position 1, C at position 2, A at position. Observe here. Here A at position 1, second interval A at position 2, third interval A at position 3, like that. In first interval A at position 2, second interval position 3, third interval position 2. C conductor or C phase is also 3, 1. What you understand from this diagram, this transposition is all three conductors A, B, C occupies its all three conditions. First interval 1, 2, 3, second interval 2, 3, 1, and third interval 3, 1, 2. Observe here 1, 2, 3, 1, 2, 3, 1, 2, 3. All three conductors having three positions. If you calculate the inductance for this case, we can get LA equals to LV equals to LC, and capacitance is also. Okay, therefore, the line inductances are same. If line inductances are same, its drop LA equals to LV equals to LC. We are sending a sending end voltage with the transposed line. The receiving end receives. The LA, LB, LC are same. Therefore, drop is also same. If drop is also same, then receiving end voltage is same. I will explain with the example by taking numerical values. What the difference between? Clearly, easy. Suppose it is a untransposed transmission system, untransposed case. So these are the three. I am sending 100, 100, 100, but LA, LB, LC are different. Here drop is 2 ohm, 3 ohm, 4 ohm. The current is same. Assume that 1 ampere, all the current having 1 ampere. Therefore, here drop is 2 volts, here drop is 3 volts, here drop is 4 volts. Then here I am getting 98, 97, 96. Are you called it is a balanced transmission system? No, it is unbalanced voltages are present because the different values indicates that different balance. Therefore, now with the transposed system, it assume that it is a transposed one. Okay, transposed one means all the three conductors are occupies its three positions. Therefore, LA equals to LB equals to LC equals to same. Assume that all are having 2 ohm. All are having 2 ohm by using this transposed system. Assume that the current is same 1 1 1. Therefore, LA, LB, LC are 98, 98, 98. Then it is called as a balanced voltage. Okay. For making balance, we have to make inductances are same. How we can make inductances are same? With the help of this transposed system. Okay, by doing the transposition, the inductance values are same. Now we will discuss what are the advantages of this transposition. Advantages. What are the advantages? First one is, in transposed system, all the inductances and capacitances are same. In capacitances also. Capacitance is also same. It is happen in transposed systems only. Next, acoustic shock. Acoustic shock is, and acoustic shock and noise is reduced. Acoustic shock and noise is reduced with the transposition system. Okay. Now, the radio interference. Radio interference is eliminated in communication lines. What is this radio interference in communication lines? Suppose this is a transposed system. Assume that it is a transposed system. Parallelly, the communication lines are there in that same tower. It is power line, it is communication line. Okay. Now, A at 3 positions. A occupies first position, second position and third position. In first position, A is, assume that it is 1 at an angle 0. At position 2, it is 1 at an angle 120. At position 3, it is 1 at an angle 240. Therefore, amount of electrical, the inductances induced in the communication lines. Okay, induced voltages are 1 at an angle 0 plus, 1 at an angle 120 plus, 1 at an angle 240 is equals to 0. Okay, that's why the radio interference or induced voltages are from power lines to communication lines is reduced in transmission system with the help of transposition. Okay, next fourth one. Fourth one is but in this, by doing this, we are doing this one in transmission lines, but practically, okay, first before going to that we will discuss the disadvantages of transposition. What are the disadvantages of transposition system? Nothing. Okay, we have to change the position of the transmission system. Here there is no drawbacks. Only one thing is we have to take care of changing the position of the conductor. We have to take care on it. Okay, here conductor A must occupy all three positions, B all three positions, C all three positions, then only it is called as we will get LA equals to LB equal to LC. Otherwise it is not possible. That is the only drawback in transposition. Otherwise there is no transposition. Where we are doing the perfect transposition, means all the conductors occupies all the positions. There is no drawback in transposition. Okay, here one thing we have to know here, practically we are not doing transposition at towers. Okay, it is done in switching stations. Okay, it is done in switching station. I will show some practical transposition systems. Some practical transposition systems in overhead transmission systems. Okay, here this is transposition, conductor A, conductor B, conductor C. Conductor A is red color, it occupies 3 positions. B also occupies the 3 positions and C also occupies the 3 positions. This is the way we will do the transposition. Okay. Here in this diagram we observe that they are changing the position of 3 conductors. Yellow is one phase, red is one phase and green is another phase. Okay, here green is another phase. This is, here observe that it is specified in one color, it changing the position. Now here it is in middle, now turned into corner, it is in middle, it is going to the corner. Okay, observe that it is not highlighted with the colors in this diagram. Here I highlighted this. Yellow wire occupies middle, this green top, the red one is another one. Okay, this is the way we will change the position of the conductors in practical cases. Okay, this is the transposition of double circuit. Up to now we discussed single circuit. In the next videos we will discuss double circuit. Assume that here the conductors, both the conductors are same cross up, then it is untransposed. There is no change in position. But here same color indicates that same conductors. Here the conductors are A dash are at same cross up, but in transposed case A dash are different. B dash are same cross up, but C dash are different cross ups. Then it is termed as a transposed double circuit line. We will see in next class. This is about transposition of transmission lines. Okay, if we have any doubt in this topic, you can comment. I will answer that questions. Okay, thank you very much.